Hi students, today we can discuss the class 10 chemistry chapter 1 chemical reactions and equations. See, in this chapter we are going to deal about the different types of chemical reactions, how to write a chemical reaction and how to balance a chemical reaction, etc. So first of all, what should we should understand is what is a chemical reaction. See, we know that a chemical reaction is a process in which one or more reactants are converted to one or more products. And during a chemical reaction, chemical change occurs. It's not a physical change. If there is a chemical change, only we can call it a chemical reaction. The substances that undergo chemical change are called reactants, and the substances that are formed are called the products. See, here in the example we can see that there is a reaction which shows burning of methane. See, the reactants are methane and oxygen. Methane combines with oxygen to form carbon dioxide and water, and methane and oxygen are called the reactants, whereas carbon dioxide and water are called products. So LHS, or on the left hand side we have the reactants and the right hand side we have the products. Now if we go for an example of a chemical reaction, see, the picture shows that it is burning a magnesium ribbon which is holding in a pair of tongs. And the one thing what you have to be very careful about this is the magnesium ribbon should be clean. It should be cleaned before we start the experiment. And if we can say that if we burn the magnesium ribbon, we can see that there forms a very dazzling white flame, and we are getting a white residue in the china dish. We call it magnesium oxide. Okay, so in this reaction, magnesium is combining with oxygen in the air. Okay, so and what is the result? So, flame is produced, and there is a evolution of a gas, or and we have a residue also. Okay, then another example is there is we have in two test tubes in which we have colorless solutions. In one we are having lead nitrate, and the other we are having potassium iodide. Okay, so when we mix these two colorless solutions, we are getting a colored precipitate, or a color appearance of a color we can see in this reaction. Okay, so what is happening here is yellow precipitate of lead iodide. So while the lead iodide is getting precipitated, we will study later. Okay, so that's it. And in the next example we can see that, so we are taking, you see the conical flask, we are taking some zinc granules and we are adding dilute sulfuric acid using the glass tube. Okay, then we can see that gas is being evolved. So in the previous example we saw there is a color change, and in this example we can see an evolution of gas is taking place. So when dilute sulfuric acid reacts with zinc granules, the evolution of the gas is taking place, and we can prove if you bring a burning matchstick near the mouth of the test tube or mouth of this glass tube, we can see that it catches fire. It proves that, and that also there is a production of pop sound is heard. That proves the gas evolved as hydrogen. Actually, that is the test for hydrogen gas. Burning matchstick goes off with a pop sound. Okay, and we can see that at the glass tube, at the tip of the glass tube, will be a flame appearing, where the gas that is coming out is burning. Okay, then So as a summary, we can say that when do we can say that there is a chemical reaction taking place? A chemical reaction is taking place when there is a change in state, when there is change in color, or if there is an evolution of gas, or there is a change in temperature. So in this case, there is a change in state, change in color, evolution of gas. And in this case, we can, in the reaction between zinc and sulfuric acid, we can see that there is, if you touch the surface of the beaker, we can feel the heat produced. There will be evolution of heat also taking place in this reaction. So that means there is a change in the temperature in this case. So that gives, so if this any of these things are happening, or any of these one, or if there are two, so sometimes there may be two or three even. Okay, we can say there is a chemical reaction taking place. Okay, so now the next task is how to write a chemical reaction in a simpler way. Okay, so first we can say that the simplest way is word equation. For example, the same reaction where magnesium catching fire, or if you burn the magnesium ribbon in oxygen, we can say that, or we can write that using the words like magnesium plus oxygen gives magnesium oxide. We are writing a plus symbol, it shows that the reaction is taking place between these two, and we are writing a right-headed arrow, which shows that this is the direction to which the product is being formed, or this is the direction of the reaction. From here to here is the direction of the reaction. To show that, we are showing a right-headed arrow. Okay, so that is a simplest way of writing. It's a word equation actually we call it. But that is not a simple way, or it is very difficult if, in the case of complicated reactions and all, writing this way is becoming a task. So to avoid that, we can go for chemical equation, or using the help of chemical formula. For example, instead of magnesium writing the simple complete word, we can use the letters Mg for the symbol of magnesium, O2 the symbol of oxygen, and MgO for the symbol or the chemical formula of magnesium oxide. So writing this way, we call it a chemical equation. Why equation? Why the word equation is studied. Okay. So this is a reaction which shows magnesium is combining with oxygen, giving the product magnesium oxide. But once you observe the reaction carefully, we can see that the number of oxygen atoms, magnesium is one atom on the left hand side and one atom on the right hand side. But oxygen, there are two atoms on the LHS, whereas there is only one atom on the RHS. So this equation is not balanced, or it is an unbalanced equation. We call it a skeletal chemical equation. Whereas if we add the words, numbers 2Mg plus O2 gives 2MgO, then the reaction is balanced, and we call it a balanced chemical equation. Now the word equation is apt because it is equating both the sides. It is equating the number of elements, number of atoms present on both the sides are equal. Okay, so the word equation is meaningful here. Now, so writing the skeletal equation, balancing the equation. Balancing the chemical equation is the next task we have to understand. Okay, so why we need to balance an equation? That the law we are following is law of conservation of mass. That law says that mass can neither be created nor be destroyed in a chemical reaction. That means in a chemical reaction, mass remain the same. LHS the mass and RHS the mass of the same element remains the same. Or can say the total mass of the elements present in the products is equal to the total mass of the elements in the reactants. So since mass are equal, the numbers also has to be equal. So what we are going to do while balancing a chemical equation will be equating or will be equalizing the numbers. So here is a simple method to balance a chemical reaction. So the first step to balance a chemical reaction is shown here clearly. What we have to do is we have to draw a table like this, and we have to write, for example, the equation given here is zinc plus sulfuric acid. First, if the formula is not given, you have to go for the formula. So here the formula, it is given, word equation is given like zinc plus sulfuric acid gives zinc sulfate plus hydrogen. We are converting that into chemical equation, chemical formula. Using the chemical formula, Zn plus H2SO4 gives ZnSO4 plus H2. Okay, so the first step for balancing a chemical equation is draw a table like this. And the first step is write the elements present. Here zinc is there, we have written zinc here, hydrogen is there, hydrogen we have written, sulfur is there, oxygen is there. So we have written all the elements in the first column. Then we'll write the number of atoms, each element, for each element, okay? In the LHS and on the RHS. So in the case of zinc, we know it is LHS we have 1, it is written up, and certain RHS also it is the number is 1. Okay, so we don't have to worry about, but hydrogen, when it is coming to hydrogen, that is hydrogen is also 2 LHS, here we have 2. Then comes sulfur, 1 each. Oxygen only, oxygen is 4 on the LHS and 4 in the RHS. See, so here it is written both. Now all the elements are equal on both the sides. So what is the skeletal equation itself is a balanced equation. Okay, so thus it is a balanced equation. We don't have to go further balancing it. Okay, so once we have written this, we understood that whether the reaction equation is balanced or not. But if the equation is not balanced like this, see here the example given is iron is reacting with steam producing iron oxide and hydrogen gas. Okay, so the equation is not balanced. From iron it is 1 only, here we know it is 3. Hydrogen 2, there it is balanced. Oxygen 1 only, here but 4 are there. Okay, so first we complete the task here. The first step is, before that, the first step is draw the equation in a proper way and draw a rectangular box around it, so that to make sure that we are not going to do anything inside this box. We are not supposed to change the formula of an equation or formula of chemical formula, the number of atoms we are not supposed to change. To avoid that, we are drawing in a rectangular box outside the formula. Okay, then the next step is you write the elements in the LHS and the RHS. But from here we can see that iron is not balanced, oxygen is also not balanced. Okay, so here 2 elements are not equal on LHS and RHS. Okay, so our first step is over, our second step is also over. Now the third step is, actually here it is, that I'll say from here itself. See, from third step is, see here we have 4 groups, and if you go for the chemical formula of the compounds here, this compound is having maximum number of atoms, and in that oxygen has got the highest number. Okay, so in order to start with balancing, what we have to do is we have to select that element which is that compound which is having maximum number of atoms, and in that the element which is having maximum number of atoms. So here it is, the compound is Fe3O4 and the element is oxygen. Okay, so first we'll balance number of oxygen on both sides. Okay, For that, see here we can see that LHS we have only one, whereas in the RHS we have four, right? So we can make the oxygen 4 on the LHS. For that, what we can do is we can write 4 over here. We can write a 4 over here, but not inside, outside the box. Okay, we wrote a 4 over there, and now what happens is this 4 is multiplied by H2O. That means now we have 8 hydrogen and 4 oxygen. Okay, so 4 now but the oxygen is balanced, right? 4 oxygen on the LHS and 4 oxygen on the RHS. But what happened? Number of hydrogen is changed. How many hydrogen atoms are there? We have 4 into 2, 8 hydrogen on the LHS, but we have only 2 hydrogen on the RHS. So what we can do? Have to make it 8. How can we? 2 is multiplied by 4 will be 8, right? So we will write 4 over here. Okay, so we got 4H2. So hydrogen is also balanced, right? Oxygen is balanced, hydrogen is balanced. Now what is the problem? The problem is with the next element is iron. It is 3 elements are there on the RHS, and we have to make it 3 over on the LHS. We will write it 3 here, right? This is now we have balanced all the elements. There's only 3 elements are there. We have balanced all the 3 elements. Now we'll check once again. We'll counter check once again whether it is correct or not. So iron again we'll check 3, 3, or hydrogen 8, 8, oxygen 4 and 4. Now the equation is balanced. Okay. Now the equation is balanced, and so that is what is shown here. Steps 3, one by one they are doing the thing. See, this is the first thing that they have done. Then they have corrected the 4H2 here. Then they have written the 4 here. Okay, now the equation is balanced. So after that it is step 5 is over. Now step 6 is we are counter checking. That also we did. We are checking once again for correctness. Now once that sixth step is over, number of atoms are equal on both sides, we can add physical states. Okay, for example, small s for solid, small l for liquid, small g for gas, AQ for aqueous. Aqueous means solutions. Okay, and S for solids, like that. So the physical states also we can add as a subscript. Okay, like this we can add, and we can write H2O. Here it is written gas. That means it is not water, but it is steam. The reaction is taking place between solid iron and steam, not liquid water. Okay, that is what is shown here. So gas symbol shows that the water is steam only. Okay, that's it. Now the finally, if it is necessary, we can include conditions like this. For example, this is a reaction in which the reaction is taking place at the pressure of 340 atmospheric pressure. That we can note using the small letters like this, 340 atm, which means the reaction is taking place at a 340 atmospheric pressure. And see here the reaction is taking place in presence of sunlight and chlorophyll. Okay, so these kind of things. Temperature also, if you want, you can write 110 degrees Celsius or Kelvin, whatever it is. You can include the temperature, pressure or catalyst in the equation so that the equation becomes more clear. Okay, that's it. Then, so that is the end of the reaction. Now, so we learned in the chapter, we learned what is a chemical reaction, what do you mean by a balanced chemical reaction, what how to balance a chemical reaction, and what are the final steps to do after balancing the chemical reaction. Now, if you go for the previous year's board and CQs, here it is showing the first example. It is showing that which of the following is a physical change. Physical change means there should not be any chemical change given as of now. So, curd from milk, burning of a candle, dissolving salt in water, digestion of food. So, it's very clear that dissolving salt in water, which is convertible, reversible, which is reversible. Okay, that is a physical change. Then it is showing a balanced chemical equation for the reaction sodium with water. So what we have to do is we have to check whether the reaction number of atoms are equal, in which case it is equal. Okay, we can find that the third equation shows a balanced chemical equation. Then another question, a shiny brown colored element X on heating in air becomes black in color. Element X compound formed. Okay, that is it is the answer is copper and copper oxide. The detailed description is coming when we are coming to the types of reactions. Okay, now I'll tell you the answer is copper, option B, copper and copper oxide. Copper oxide is black in color and brown colored compound is copper only. Then another question is, when dilute hydrochloric acid to iron filings, what happens? Actually, it is hydrogen gas and chloride produce is the answer here. Now coming to the assertion reason, there is, we know what is an assertion reason type questions, isn't it? And here is given the assertion, the burning of a candle is a physical change, and the reason is given, the wax melts but no new substance is found. See, burning of a candle is a physical change. That is wrong. It is both physical and chemical change. The explanation is given here. Okay. The wax melts but no new substance is found. Wax melts while burning, it is converting also into oxide form. Carbon dioxide and water is being produced. So both A and R are wrong. So the A is so the here correct answer is not given in the option. Okay, both A and R are false. Next question, an example is an balanced chemical equation. The sum of the masses of the reactants is equal to the sum of the mass of the products. This is based on the law of conservation of mass. No doubt the answer is A. Assertion is correct. The reason is the correct explanation. And the next assertion reason, the decomposition of vegetable matter into compost is a combination reaction exothermic. Actually, decomposition itself it is given. Actually, it is coming in the next types of reactions. This decomposition of vegetable matter is coming. Okay, where we can decomposition itself means it is not a combination. So A answer is D. A is false, but R is correct. Now short answer is given. Why is it important to balance this chemical equation? We learned in the when we learned the previous two, and there is a question given. Balance the following chemical equations. Okay, two equations are given, and the balanced chemical equation is shown here. You can try the heat and trial method, which we learned. That method is called heat and trial method. and we are getting the answer. If you are not getting the answer, we can discuss it. Okay, now one more few examples are given. Here the word equation or the sentence is given. There we have to convert that sentence into equations, then we have to balance it. Two steps are coming. Okay, hydrogen gas, nitrogen ammonia, hydrogen sulfide, sulfur dioxide. These are the thing. Only thing new to you is ammonia, and the formula of ammonia is NH3. Okay, so that's it, and we go for a few more questions, discussing or balancing few more questions in the coming videos. Okay, thank you.